Okay, question 6a is a nice trig question. Got a double angle here, so we're going to want to use our double angle formula for sine. And sine 2 theta is equal to 2 sine theta cos theta. That's when you're doing exam papers, that's the first thing I would be thinking. If they've put a 2 theta in, they want us to use the double angle formula. So 5 lots of sine 2 theta is going to be 10 lots of this. So we can have now 10 sine theta cos theta is equal to 9 tan theta. Now we've got sines and coses on the left, so we're probably going to want things to do with sine and cos on the right as well. So let's turn tan theta into sine theta over cos theta. Okay, next thing we're going to want to do is get rid of the fraction. We don't like fractions in equations, they're not helpful. So let's multiply both sides by cos theta. And that's going to give us cos squared theta there equals 9 sine theta. Now, what you don't want to do now is you do not want to divide by sine theta. You should never divide by a variable. Don't divide by x. Don't divide by sine theta, cos theta, tan theta. We want to move this over to the left instead. It's a really common error that I see in exam papers, and then factorise out the sine theta, because you can get solutions from this, especially in this question. This question ends up, the sine theta ends up giving us 3 solutions, so you don't want to be losing half of the solutions. So sine theta 10 cos squared theta minus 9 equals 0. So we've now got 2 things multiplying together to give us 0. So either this is 0 or the 10 cos squared theta minus 9 is 0. Now, when is sine theta equal to 0? Remember, the range was between minus 180 and plus 180. So it's actually 0 3 times in that range. So it's 0 when theta is negative 180, when it's 0, and when it's positive 180. So that's what I meant when I mentioned that there were 3 solutions from that sine theta equals 0. This one, we need to move the 9 over and divide by 10. So cos theta is either the positive or negative square root of that, which will be root the 9 is 3 over root 10. And so theta will be the inverse cos of 3 over root 10, or the inverse cos of minus 3 over root 10. So if we type this one into our calculator, and we're in degrees, make sure your calculator is in degrees for this question. Inverse cos of 3 over root 10 is 18.43. And when it's negative, so negative 3 over root 10, we get 161.6. And if we think about the symmetry of the cos graph, this is for cos, remember, between it's a bit rubbish, but between minus 180 and plus 180, it's dead easy because it's symmetrical about the y-axis. So any positive root, so positive 18.3, will also have the same but the negative, so negative 18.43, and the positive 161 will also have another value that's valid at negative 161.6 as well. So we have got 1, 2, 3, 4, 5, 6, 7 solutions to this. So if I just write them all in ascending order, we've got 180 minus 161.6 minus 18.4, 0, and then the same but positive. So 18.4, 161.6 and 180. 1, 2, 3, 4, 5, 6, 7. Yeah. Oops. B then, a little 2 marker, says deduce the smallest positive solution to this equation. So if you compare the 2 equations, this bit's going to be easier to work out the kind of transformation, but theta is now been replaced by x minus 25, which means the smallest solution for x is going to be the value of theta after we add on 25 that is positive. So we want to find the smallest number here, so that when we add on 25 we get the smallest positive answer. If we add on 25 to this one, it's not going to be positive. Here's not going to be positive. This one is going to be the first one that gives us a positive number. So we're going to choose when theta is the negative 18.4. And when theta is negative 18.4, x is negative 18.4 plus that 25. And if you work that out, that is 6.6. I've got it to 3 significant figures, so 6.57. I had a more accurate value of this that I used. These will also give positive solutions, but obviously this one would give 25, which isn't as small as 6.57. So that's the smallest one that they were after.